Good morning, one and all. Today we are going to see about the frequency regulation, that is one of the ancillary service management in restructured power system. So, what is meant by frequency regulation? In the sense, frequency regulation is an ancillary service that used to maintain the real-time balance between the generation and the load, so that the frequency remain close to its nominal value. So what is the nominal value of the frequency in India is 50 hertz. If you take in US and some Western countries, it is 60 hertz. In restructured or deregulated market, what is this frequency regulation is unbundling of from the energy, unbundling from the energy and procured as a separate market product. So the frequency regulation is procured as a separate market product, because you need to maintain the system frequency constant, such that your entire system will be don't have any disturbances. So this regulation is managed by the system operator. That means system operator or individual system operator or this regional transmission operators. So they will maintain this frequency regulation. Why this frequency regulation is important? Because, say, for example, if the generation is more than the load, automatically the frequency increases. Okay, so if frequency increases, not a much problem. But if the generation is less than the load, then the frequency decreases. So prevent frequency decreases, the poor frequency control may lead equipment to damage. Okay, next generator might be tripping, cascading failures will occur, complete blackouts also will be happening in this system if you not maintain the frequency constant. Next comes the frequency regulation in the traditional and as well as the restructured power market. So if you take like a traditional system, that is vertically integrated market, and as well as the restructured power system, so the main responsibility, if you take like vertically integrated utility and as well as the system operator, that means independent system operator or regional transmission operators. Okay, so they will. So, what is the main nature? Nature is a mandatory technical function should be there in the traditional system, but in restructured system, it is a market-based ancillary service. So, coming to the cost recovery, in traditional system, it is included in the tariff itself. Okay, but in restructured power system, it is a separate regulation market, because the cost recovery you can't. So you need to there also they need to get the tariff, but a separate regulation market is there. This cost recovery is they may get that. Next comes the participants. If you take in traditional system only, for frequency regulation, generators only. But if you take in restructured power system, generators, storage unit, loads, everything is involved. So if you take the control, traditional system, central utility will be there. Say for example, central utility means a grid system. So there they will maintain. But in restructured power system, competitive procurement, there they will control this aspect. So which centers, say for example, which retailers or which generators or which transmission companies will maintain this frequency constant, regulation constant. So like that, they will be preferred more in the market. Next comes the controlled hierarchy of the frequency regulation. So the frequency regulation is implemented through three-level control structure to handle the disturbances of different magnitudes and duration. First comes the primary frequency control. So what is this primary control? In the sense, frequency control is a first and fastest line of defense against this frequency deviation. What are the main characteristics? Is automatic frequency and decentralized control. Next is based on the local response. So if you see the operation like a primary frequency control implemented by the speed governors will be there. So speed governors of the generators will be there, or otherwise fast acting resources. That means battery backup will be there. Immediately it will induce the voltage in the system such that the frequency will be maintaining constant. Next, response immediately when the frequency deviates. Okay, that means primary system, primary frequency control system. Okay, next, it does not restore frequency to the nominal value, only arrest the fall or rise. Okay, so in this, it will does not make the frequency to restore it to its normal value, but only it arrests that frequency fall or rise. That only it will maintain. Next comes the key param features. So if you take the parameter activation time, the primary control 5 to 10 seconds. If you take the control method, governor Droop will do. Next, if you take the nature, it is automatic. Objective to stabilize the frequency radiation. Next is a frequency range. Next is a restoration. So primary control, there is no control. Okay, example, if you take a 500 megawatt generated trips, if the frequency starts falling. Okay, so governor of the nearby generator increase the power automatically. So governor of the nearby generator increase the power automatically such that frequency drop is arrested. So these are the main mechanism in the primary frequency control. Coming to the secondary frequency control, secondary control restores the frequency to its nominal value and corrects it using tile and power deviation. So it is also known as automatic generation control. Okay, AGC. Okay, so in this automatic generation control, what is the main operation? There will be a centralized control that will be handled by a system operator. Okay, they will operate this automatic generator control. Okay, so uses area control error. So what is this area control error? Tie line power minus scheduled tie line power into plus this B. Okay, B is nothing but frequency bias into actual frequency minus nominal frequency. So this is how you need to calculate the area control error. So what is this B? B is nothing but frequency bias. So what is this AGC, automatic generation control? Sends the rise signal or lower signal to the selected unit such that immediately they will increase, it will increase the generation in that generator, generation in that particular generator, or otherwise immediately reduce the generation in that particular generators. Next, if you take like parameters, response time of secondary control 10 seconds to 10 minutes. Okay, so response time is somewhat fast compared to the primary control. Next, control centralized. Okay, centralized control, some operator will be controlling. Automatic control. Next, signal is automatic generation control. Objective is to restore the frequency. Tie line correction, yeah, it is having the secondary control having the tie line power correction. Example, say for example, after a disturbance, frequency stabilizes at 49.85 hertz. So automatic generation control slowly adjusts the generator output such that frequency returns to its 50 hertz. So this is also happening in the secondary frequency control system. Next comes the topic called territory frequency control. So what is the main concept behind the territory control, which handles the sustained or large imbalance and prepares the system for future disturbances. Okay, so which handles a sustained and large imbalance that will be handled by this territory frequency control. So how it is operating? It is operating based on manual or otherwise based on the market based dispatch. Okay, next the replacement of exhausted secondary reserves. Next, by using the economic redispatch of generators. So like that, this territory frequency control gets operating. So what are the key features in this response time? If you take the territory control, response time is 10 to 30 minutes. So control by manually or market based control. So objective is long term balance. Okay, long term balance. Restore of the reserves is yes. So it is restoring the reserves. Example: a large thermal unit is out for a service of several hours. New generators are scheduled to maintain the balance. Okay, so new generators are immediately scheduled. That is called territory frequency control. So comparison, we are comparing this primary control, secondary control, and tertiary frequency control. So if you take the speed, primary control is very fast, secondary control is somewhat medium, tertiary control is slow. Next, control wise, primary control is local, secondary control is central. That means AGC. Next, territory control is manual. So you need to manually switch on. Automation, primary control is full, secondary control also full, territory control is partial. Okay, frequency restoration, primary control it is not there because it will just withstand the frequency. But in secondary control, frequency restoration is there. Territory control also frequency restoration is there. Next, market involvement, primary control no market involvement, but secondary control market involvement, tertiary also market involvement is there. Next comes the frequency regulation as a market product. In restructured system, frequency regulation is treated as a economic services because if you take the procurement methods of this service methods is mandatory. So mandatory for as per the grid code. Okay, so minimum this PFCs are maintained. Next comes the bilateral contract. So bilateral contract, this service operator, system operator contracts with the providers. Okay, next, competitive market, bids for regulation up and regulation down. Okay, so these are the procurement methods for this frequency control. Next comes the co-optimization. So energy and regulations are cleared simultaneously, which ensures the least cost dispatch. So we are always looking for the least cost generators that to be dispatched such that our price tariff will not rise. Okay. So next, it avoids inefficient reserve allocation. Inefficient reserves allocation. So example, a generator may earn more from the regulation than energy during the low load hours. Okay, so a generator may earn more from the regulation than energy during the low load hours. So in that regulation, they need to maintain that system frequency constant. No? That time, if you pay more, then automatically, then generator companies will maintain this regulation such that regulation will be very less. Regulation should be less and efficiency should be more. Okay, regulation if it's zero means system is efficient. Regulation should be very less. Okay, so performance based remuneration. So if you take like modern markets pay not only for the capacity but also for the quality of service. That means frequency they are maintaining or not like that. So metrics. Say for example, if you take capacity payment, reserved power should be there. Next, mileage payment, the amount of movement, that also it is called mileage payment. Okay, next comes the accuracy. So accuracy, tracking the AGC signals, automatic generation control signals that will be tracking. So that accuracy also should be made. So response time is speed. Okay. Next, if you take like a regulation up and regulation down products, regulation up products, what is the main function? To increase the generation and reduces the load. So regulation down means decrease the generation and increases the load. Okay, decrease in generation and increase in load. Regulation down means regulation up means increase in generation and reducing load. Next, what are the emerging trends in this frequency regulation field is so impact of renewable energy. So if you take like solar and wind power, variability will be there. So what is the main effect there? Means which increase the frequency while volatility. Next, reduced inertia will be there. Next, fast frequency deviation will be there. So if you take the frequent forecast errors, higher regulation demands also will be there, which leads to fast frequency response. Okay, which leads to fast frequency response. Next comes the battery energy storage. Battery, if you take the battery energy storage system, um, battery energy storage system becomes the most efficient regulation sources. Okay, so if you take the feature of that battery energy storage system, the response time will be in milliseconds, because battery energy storage response time in milliseconds. Immediately it needs to be restored. Next, accuracy is very high. Bidirectional. Okay, if you take the bidirectional features, yeah, battery energy storage system, bidirectional, yes. Okay, mileage earning. So we can call this mileage earning is maximum in battery energy storage. So nowadays they are using BESS, that is battery energy storage system. So if you take the demand side participation, loads can now regulate frequency. Okay, so if you take like a industrial distribution regulation, industrial regulation, distribution regulation, temporary load reduction will be there. Next is aggregate. Say for example, power producers aggregates small resources. Okay, so that in which they can maintain the resources. Okay, so power producers for a short time. Next, if you take like smart loads, EV charging controls. Okay, method smart loads means EV charging control system also it is there. So this is all comes under the demand side participation. Okay, if you take like a Indian context, Central Electricity Regulatory Commission is there. Okay, so this is also one of the ancillary services, service regulation under 2022. So here the mainly shift from the regional dispatch center control research to market-based ancillary services. Okay, in the Indian context. So target frequency band is 49.95 hertz to 50.05 hertz. So what are the main features of this particular thing is, if you take like control area, in India it is maintained by National Grid. Operators are, it is maintained by POSCO. POSOCO. That means Power System Operation Corporation. Next comes the regulation resources. Regulation resources, majorly thermal-based regulation is there, hydro-based regulation is there. Next, battery energy storage system is there. If you take like market evaluation, real-time ancillary services market also there in India. Okay, to maintain all this frequency level constant.